Well, she planned to not be here. I'm doubting that she's sick. Ava, whether you're playing hooky or, actually sick, feel better or get back soon, whichever applies. So, we today are going to actually, oh yeah, Ava, sorry, you're going to miss using tangent. We're going to use tangent today. Woo-hoo. So,
What was that?
That was a maniacal laugh. Now, hold on. Bring it in. We talked last week about the Leaning Tower of Pisa. Can anyone remind me what we figured out, what we talked about, what we were concerned about, what we hypothesized? Like, some of us had, what we thought was the angle of the tower, right? And you were very frustrated because I never came back and I never gave you the answer, and that was intentional.
Thanks.
Art, really? So the concern, right, is that if it dips below 83 degrees, if it tips beyond that point, they're guessing it will likely fall. And they've done some physics, and they've figured this out for a specific reason. Or, in a specific method. Sorry, not for a specific reason. The reason is obviously, will it fall or not? What did we think it was? 84.5. 84.5? What was our slope ratio when we talked about the slope of the tower? Because we figured it out two different ways, right? We laid the it was 10, or if we turn the triangle a different way, we found a slope also of 1/10, right? So we can talk about the slope as 10 or 1/10. Now, really, when we talk about slope, how do we talk about slope? How do we find slope? Rise or run, right? Change in y, change in x. Okay. So, we said, hypothetically, 84.5 degrees. Now, how did we figure that out? Now, you're very, very close. 90. No. 90 would be standing up.
I know. Yeah, Jay.
It's obviously not
The
right.
actual angle of leans is 84.3. Is the actual angle. Now, given the skills that you had to solve this and the knowledge base we had and everything else, you couldn't really get to that point of accuracy. Now, it'd be really, really tough to get there, is what I mean. So if I say, you couldn't get there, of course, that's not a challenge. I bet you can't. It's just saying it'd be tough, right? It'd be hard to get to that point. So, we used our trig table, right? Go ahead and pull that trig table out that we had last week, that resource page. We used our trig table as we talked about all this. Let's use what we know. Our trig table, our info that we've gathered, collected, and verified so far, even if it's slightly approximate, to try to look at 3-100 situations A, B, and C, and solve for those unknown values. So as a group, try to agree on A, B, and C, the unknown values here. It is the 23rd today. Your trig table. So what from our trig table is going to be useful when we start to look at A? We might as well use cards. There's some useful. Ryan, what do you think? What's going to be useful as we start to solve A? From the trig table. The 11 degree one? Okay, why?
Because since it's 90 degrees and 79 degrees, the theta would have to be 11.
Okay. So because of my triangle angle sum theorem, I know that that's 11. Now, actually, knowing that it's 11 is like part of what we're trying to do here, right? Because that's one of my unknowns. So we label that as 11 degrees. Please make sure you have a label. How else is my trig table useful? What other information is on there that can benefit me? Yeah.
79 degrees.
Okay.
Do some reflections and resistance. It will be the W and the 12, which since the angle is 79 degrees, since we're at angle, you can know that it will be a ratio of 5 to 1.
Ooh, so we can use that ratio, right? We've got two ratios, and I have them up on the TV. The 11 ratio is 1 to 5, rise to run. The 79 ratio is obviously the flip of that, the reciprocal, 5 over 1. Which is good. Well, it depends on how you're looking at this here. But if we say that the rise is our unknown, is our rise going to be 5 times the run, or is our run going to be 5 times the rise? Even?
The run's going to be longer.
The run has to be longer because it is opposite the larger angle. So, means to find my rise, or my W, depending on how you look at it here, what do? I know my rise will be what compared to my run? Not 5 times. 1/5 times. Right? Because if so my run is 5 times my rise, but if I say my rise is what of my run, my rise would be 1/5 of my run. So to find my W, we could just calculate using that slope ratio. Well, 1/5 of 12 then would have to be, 2.4, right? Approximately. You can say we're pretty darn close. Not 100% sure. We're right about there. Use that sort of information to solve B and C if you have yet to do so. If you get done with this one, move on to the next problem. What's this theta gonna be?
Well, 72. It's 72 degrees.
Who can tell me how I can think about Z to get it figured out, to get it solved? Okay? Wait, what? I just couldn't hear you.
Well, the way you're doing it is like, because the slope ratio is like 5 over 2.
So are you using the 22 degrees or the 68 degrees? So if we're using 68, that's 5 to 2.
Yeah, which is 2.5.
Okay, 2.5. So you say that to find z, we're going to do 2.5 times 8.
Oh, yes.
No.
So what you're saying is correct, except you're using the wrong reference. So if you reference the 68 degrees, you are working to solve something related to that 68 degrees.
Oh, because you're solving for the opposite.
Because the length of the side relates directly to the opposite angle. So if I want to solve for z, I need to relate back to 22, and 22 tells me the slope ratio is 2 to 5. So z has a ratio of 2 to 5 when compared to, or when working with, the other leg of 8. So it'll be 2/5 of 8, or 16/5, or
See, I had
16/5.
it right
That's
the
easy.
first
16/5.
time. I had it right the first time.
What'd you get then?
I got 16 bits. And then I did something and then I just
So it's 3.2, right? 16/5 would be 3.2. For x here, would we be using the 18 degrees or the 72 degrees? The 18 is the easiest, right? Because that goes directly to my x. So when we think about 18 degrees, how does that side relate to the other leg? What ratio does that involve?
That's 5.
The leg related to the 18 degrees will be 1/3 of my other leg.
Which is 5. Yes.
18 degrees.
18 degrees is 1/3.
That ratio is 1 to 3 of rise to run.
Yeah, I thought the size of that was going to be
6/19.
Okay, so we're using what we have on the table. We went back and we tightened up some of those, right? Because we were talking about the difference between the approximate and the exact. Right now, we're fine to use the approximate. We're just trying to get you to understand it, and those approximate values are going to be easier to work with than the exact. I agree with you. We went back and calculated some exact values. Don't worry about that. So, sorry, C then comes out to have an x of
5.
5.
I have a question.
Yes.
Are you ever going to put the desk box in how they were last year?
Never again forever.
They were so nice last year. What was last year?
Okay, you're mad at CPM because desk placement.
Summer course.
No, wait, what was last year?
Summer course. It was like bunch over.
It wasn't as claustrophobic.
Sorry that you have to be close to talk about math with your peers. So, moving on. That's interesting, right? We can use what we know about the slope to determine. And if we really wanted to be precise with what we're doing here, right, we would say, like in a situation like this, the rise to run in this triangle must be 2 compared to 5, when I know that the larger leg is 8. What we're saying is what value up top would make this a true proportion. What we're really solving is 2 slopes equal to each other using different rise or run values. Rise, run, 2, 5. Rise, run, we know the run of 8. The rise would have to be 3.2. Make sense? We're really solving proportions, but we can quickly do it just using that ratio. So, we're using slope ratios to determine lengths. Sounds like a branch of mathematics that would be worth giving a name to. So, May, Tiana, Lynn, Eddie, and Amy, gosh, a lot of people, are looking at this triangle. They're all crowded around, very excited about this triangle. Tina declares, hey, we can rotate the triangle so 18 degrees. Tiana, sorry. Stop. So, we can rotate the triangle so that the 18 degrees looks like a slope angle. So what do they mean, looks like a slope angle?
Well, they make the 18 degree like the top vertex.
The top vertex. Like they spin it so 18's up at the top? If it is the slope angle, Chris, you said no.
Then by rotating it, the 18 degrees will be on the straight left.
Ooh, we would like it that if I created like an XY, that I could just look at, okay, 18 degrees is my slope, right? My rise and my run relate directly back to that 18. So Tiana's visualizing this, right? She says, we can do this. And, we are then asked, will her method work? So we'll come back to that. Maylin says, I see it differently. I can tell that the delta y is 4, okay, without turning the triangle. Which I argue that really you did turn the triangle. You maybe didn't physically do it. Eddie says, well, I know based off triangle angle sum we have a 72-degree angle here. What if I use that as my slope angle? Right, so he's using 72 down here. Then his delta x is 4. Okay, Eddie. What do you think? What would work? What's most efficient? How would you solve it? Take a couple minutes. Figure out what A would measure and how you know.
Times 4, right?
Yeah. 4 is 30. Wait.
Yes.
12.1.
Well, actually.
Do they? So wait, are we gonna act like they have this or if you don't have this?
Well, you know what? We'll use some. Yeah, I heard you said that like 10 times already. No, thank you. Yeah, I know. Oh my god.
All right, I'm going to start really basic.
It's true.
Really basic, like pumpkin spice latte.
What? I had one against
So,
Thank you so much.
So, what do we know immediately about A? Don't give me any nitty-gritty matches. What do we know immediately? What observation could be like, oh, A is going to, something really simple, be larger than 4. Why do you know?
Because the angle's on the opposite side.
Because we know Hinge theorem tells us bigger angle, bigger size. Perfect. Then we know,
What?
thanks, you're going backwards. Then we know, based off our trig table, certain angles hold certain ratios. Right? We don't have every angle up there. God, that would take forever. Challenge, discovery day. But we have some reference angles, and a good amount of them. What is our reference ratio for a triangle involving an 18-degree angle?
0.3.
Don't give me, when you say ratio, let's not use decimals.
Yeah,
That's like,
1.
you're better than that. You're better than that.
Okay, if I want to be extra.
1 to 3, right? We know we will rise 1 unit for every 3 we run. We rise 1 for every 3 we run. So we know that we rise 1 for every 3 that we run, based off that 18 degrees equaling a 1/3 ratio, and that's really like an m of 1/3. This is kind of messy. You have to know what we're talking about here to understand why that makes sense, right? So if I have a rise like whatever Tiana describes, rise of 4, how does that help us solve? What must our run be? Why? What? Say it louder.
Well,
Why 12?
because the 4 has to be 1/3 of the A, so 4 times, and you can reverse it and make 4 times 3 is 12.
When opening, I love how Ryan said that. I'm going to add in when opening at 18 degrees, the rise is 1/3 of the run. Doesn't matter how big the triangle is. This, because the angle, this can only be 1/3 of the bottom portion. So A then has to be 12. Just like if we look at it the other way and we use the 72 degrees, which I wrote in fluorescent green because I don't really want to solve that, we get flipped around and we know that the rise is 3 times the run. And then if our run is 4, our y is then has to be 12. So, knowing certain properties about certain triangles, and we could actually, like I said, take a while and build this table for every angle measure. And then if we were going to build this table, Mr. Sharp, we would probably care about the accuracy, like you said. Which one had we fixed last week? I forget which one we wrote the better. 11 degrees, we fixed 11. We went back and we did the more precise on one of them. And we could do that with each angle. And that would lead us to trigonometry. So, our next question here then involves this triangle. So look at problem 102. Look at 102. I will immediately put one at each group, and then there's still 2 extra, and whoever has their own or whatever. I'm not going to simply break it if you want it. Here, also somebody can use mine. Here, somebody can use mine if you don't mind. We want to get comfortable with these. If you're not on an 84, get with somebody on one. Before you hit anything, we need to check what's going on. Hit mode. Mode is going to give you the base settings of your calculator. Hold up. What part of this menu do you think we care about right now? Not the set clock. Cobble? So on the 4th row down, it says radian or degree, and radian is probably highlighted and flashing. Radians are a unit of measure in mathematics. Just like feet and yards, a radian is a unit of measure. We'll get into that later. We're not working with radians yet. Switch that to degrees. So highlight degrees, hit enter, and that's how you switch a setting into 84. Then hit second quit and get back to the main screen, where you can normally hit clear. You're on it. It has been selected. So now that it's up, so now second quit. So what has been done here is that somebody, probably everybody's favorite mathematician, decided that they wanted to make that trig table for not only every integer angle, but every angle measure possible, period. And they have added this information into the hard drive of the calculator.
Good for that.
And your calculator can quickly compute the ratio given either the input of angle opening or radian opening. We'll get there, we're not there yet. And then do the calculations for you. Now the problem when we had you guys just memorize SOHCAHTOA is not understanding what it's actually doing. When we talk about TOA, right, tangent, when you say SOHCAHTOA, what does that mean? What is how does TOA how does tangent become TOA? What the heck is that? What?
Opposite over adjacent.
What do you mean? So I just.
The O and the A is the opposite.
So this is really that.
Opposite side over opposite angle equals. Opposite over adjacent equals the angle.
Close.
Tangent of. Sorry.
What were we just talking about with your trig table?
The ratio.
The ratio of what? What makes slope?
An angle or triangle.
All right, but what 2 things do we talk about when we talk about slope? Rise and run. What this is actually talking about some triangle with an angle that is our slope angle will create a slope of a certain proportion, which is your O and your A. The only thing that tangent is doing, saying, oh, where in the trig table can I find your rise and run ratio? And then, based off the standard ratio, like 1 to 3, 2 to 5, whatever, relate that to the triangle you've given. Because if you know the angle and the opposite and the adjacent, there's no need for you to do trig. We are assuming that you're doing trig because you're missing a piece of information. So up here, we've got everything, right? So according to the triangle at the right, what is the slope ratio for 32 degrees? So let's start answering these things. I want to give you a briefing on tangent before we get into this problem. So there's your quick briefing. According to this, a triangle with angle 32 degrees, so we would say tangent of 32 degrees, because what tangent means is what's the ratio. So what we're being asked in 102A is what's the tangent of 32 degrees? What ratio does that create? Well, what would be the ratio? Ooh, other way around. Because remember, if this was our angle sitting on the XY and we look for rise and run, rise is opposite, run is adjacent. So rise and run, this slope ratio is now 5 to 8. Right? According to this triangle, if this triangle is true, that's our ratio. Are we cool on that? All we did was look at the slope. 32 degrees actually means slope of 5/8. Question. So then, what's the slope for 58 degrees? Eight over 5, right? It's just the in. So actually, every time we know one angle, we know two angles. So, well, I mean, still, then you get confused. Is it 1 or 2? Are they the same? So really, you only have to do this 45 times, right? Because every time, every angle you do, you get 2. Okay. So type in tan 32 degrees and close that parentheses. Sometimes it'll work if you don't close it. Sometimes it will not work. So type in tan of 32. Close that parentheses.
I already did that with calculation.
What do you get?
It's around 0.625.
So hit enter.
What do you like to round it to?
Now,
Nearest
this 5/8, and that 32 degrees. That's as close as we get for the accuracy that we care about. So your calculator does not come up with exactly 0.625, right? You got to round eventually. So realize that in trig, there is a little bit of rounding that is acceptable, because you can't literally go to every like hundredths or thousandths of a decimal value or of that length value, but the ratio comes out to be really approximately very, very close to 0.625. Right? We could say 5/8. Do it again, type in 58. Well, tangent of 58. Right? And you can just go back up in and change 32 to 58. What do you get?
1.6, which is close to 1.6.
Which is really darn close to 1.6. Okay, let's move on. Well, I'm making up stories, but essentially, I mean, you can have a computer program do it for you. You would just set up like, okay, to get this value, do this and do that, and then it would do it all for you.
If you were to calculate every one, though, it would never be done because there's an infinite.
Right, yes, exactly. But a computer can continue to calculate forever. Like, we are still calculating decimal places in pi.
Yes.
So check out 103. How then can we use that button? Let's say we don't yet understand how to work with trig, because really you don't. Like, you get it, you've memorized the SOHCAHTOA, but you don't really get it yet. 38, right? So we see 38. And we know that if we talk about 38, it's going to be slope will be that over that, right? If we laid it down flat and we made that to 38 degrees. So when you type in tangent of 38, what do you get? Hold on. What do you get?
7.81.
Are you in radians or degrees?
I'm in degrees.
What'd you get?
You were saying I got
Not point.
Yeah, I got
7.
0.78128.
Mm.
Yeah, you have something way.
You might be in radian instead of
0.7.
812
Redo it then.
or 813
Okay.
if we were gonna round it.
So hit math frac. Try to see if it'll turn that into a fraction.
No, it will not.
It will not.
Uh-huh.
Were you in degrees or were you not in degrees?
Yeah,
Word?
it doesn't turn out.
That does not work.
No. Yeah, I'm in
Oh,
degrees.
it did.
Oh, you're in scientific. It's making it scientific notation.
Why?
So because you're in scientific notation, it will make every answer scientific notation. So now if we do that again, there you go. Always check your settings. If things seem weird, always check your settings. So, hold up. So if we took the long way around this, that tells me that the rise to run, well, I could say like 78 over 100, right? Approximately our rise to run is 78 hundredths. So then I could say, well, if the run is 8, right, how do I divide to get there? Well, if we remember those quick facts, it's not nice, but it's sort of nice. How does 8 work with 100? What's that decimal do you get? Yeah, 12.5, 0.125, and 8. So 12.5 would be the division there. What's 78 divided by 12.5?
So actually 6.24.
Approximately. Right, because we took some liberties along the way. We said, like, we're going to round this. We're going to, like, that 78 over 100 is close to what it really is. So we get very close to 6.24. We're taking some liberties. But if we just set up, okay, I know that this is the slope of it. If I make it a fraction to look at rise over run, so try that in B. Try to do that in B. So essentially, tangent just spits out our ratio. Now my first question is going to be, did you guys use tangent of 73 or of 17?
17.
I did 73.
Either way can be fine. Either way can be fine.
I did 73.
Sure. That was unnecessary. Oh, he's such a sharp.
Hello.
He shot Chris's book for me. So if you did tangent of 17, what was that ratio? 0. What is it?
Oh, it was 0.3057306815.
All right, 3057. Let's stop it there. I don't really go much beyond the thousandths place ever. What about tangent of 73? Who got that ratio? Okay. Is that 3.2708? So we could just put a 1 there. How does this help us? Oh, it can. Howdy Polly over here. How does this help us? This is real close to 3/10. I mean, it's pretty darn. It's like 31/100ths barely. So it's really close to 3/10. This is pretty close to 3.3, right? Like or 10/3. What we should see is that these are reciprocals,
Yeah, that
because all we did was look at the triangle in two different ways. Which way do I orient my triangle when I make it lay flat? Do I have it laying flat with this angle opening to the left, so I would have to rotate the whole thing? Or did I flip it and put the 73 and it's sticking up steep? Either way, though, how do I use that to help me? Is that 9 going to relate to the larger part of the ratio or the smaller part of the ratio? What do you think, Ellen? Would that 9 relate to the larger of the ratio? Or how do you know? How do we know which leg will be longer?
Well, you know which one will be longer by which angle is the most, so it would be like this middle side.
Hinge theorem, right? Now forget about the hypotenuse, right? So when we talk about the legs, we have a big one and a small one. Hypotenuse doesn't come into play because legs are the ones that make the 90. Hinge theorem tells me bigger angle, bigger side. So that 9 would relate to which part of this ratio? But if the 9 relates to the bigger angle, won't it relate to the bigger part of the ratio? So the 9 would be on top. Or over here on bottom. Now this is gross.
2.7. Oh!
Right, like this either way. How can I solve a gross proportion?
Calculate.
No, well, yes, but
Wait.
Cross multiply.
I got it. Wait. If you multiply it so that it's 90 over something, it's over 3 times whatever that.
ooh, we could. Okay, so I like that. That's crafty too. What if I make it 10 times what it actually is?
No, I was just comparing the two fractions.
Right. So if we make it, what's this multiplication then?
9
Times 9. So this would then become 27, but it's not actually 27. It would really be 2.7. We cross multiply. Right? Proportions. You can always cross multiply. So if I was still back at this step, 9 times 3, 27 divided by 10, 2.7. Have we forgotten to cross multiply? So, this is trig. Just trig saves us all that unnecessary time. So now, how do we do this really effectively? Now C we know is isosceles, right? 45 is going to get us another 45. So what we're really building here, and this is when it's actually really important to pay attention because I'm going to show you the quick way to make your calculator do all that work. What we really have here is tangent of our theta creates the ratio opposite side to adjacent side. In 45, it doesn't matter because opposite and adjacent are going to be the same. However, here's my trick for solving with tangent. If I wanted to cross multiply this, I have to make this into a proportion, right? Fraction equal to fraction. What do I end up with when I do that cross multiplication? Obviously, there's no numbers here, so what happens then? The adjacent does what? Multiplies by the tangent of theta and leaves opposite to multiply by 1. So really, what this becomes is to solve for an opposite side. All I need to do, did not leave myself enough space, is take the length of the adjacent and multiply it by the tangent of theta. So if I have, and guys, we know how to work with the triangles. If I know one angle and it's a right triangle, I know all of the angles. So let's pop back over to here, right? I need the adjacent side. I don't have the adjacent for 73. However, I do have the adjacent if I have this angle, because adjacent means touching, right? Right up against. So grab your calculator again. Hit 9 tangent, of course. 9 tangent 17. And close your parentheses. Because sometimes it'll group it up if you do it.
Question. Question.
And what do you get? That
Ugly
length
number.
that we just found. Do the same thing here in C. Adjacent length, which is 14, times tangent of 45. Why does this happen? What's the slope of an isosceles triangle?
1.
So that slope ratio is 1 to 1. Even though we already know it, that's the quick way. If you can choose the angle strategically, that the unknown is the opposite side to the angle, 1, type into the calculator and you're done. You got your answer. Make sense?
Yeah.
There is tangent for you. Now, here's one thing that I never understood till I got out of high school. If somebody asks you, what is tangent? What is it describing? What is it talking? What is tangent actually giving us? When we work with it, what does it spit out? The slope ratio. That's what tangent is. It's the slope ratio. That's it. That's all. That's what you need to know. Tangent is slope ratio. And now you can calculate anything to your heart's content. I am right at time, so please, quickly, we gotta wrap it up, get our stuff packed up, and head on out, because I like to respect the fact that you guys have to travel so far. Oh, so we're gonna talk about, and really we should talk about this with Ava. This is going to be so when I don't collect your like physical homework, I can get some kind of feedback. So I can find it. So for tonight's homework, you would just number like 105, 106, 107, 108, 109, 110. And then when we check it, and I need to start posting answer keys. When we check it, you would mark whether you got it right or wrong, and whether you understand it now or don't understand it. This will become more important as we get deeper into difficult content. Right now, we're still pretty good with the homework, so just hang on to it for now. We'll talk more about it as we go. Thank you. Where am I other? Yeah, we'll talk about it more tomorrow after you've done the assignment. Really, it's a post-assignment thing. Please, if you're using the 84s, do turn them off before you put the covers on. I know the solar ones don't really matter, but these we want to try to keep the batteries nice.
8, 9, pretty low. Like you're not checking.
Right.
17.
All right. Have a great day, guys.
So we get about 6 questions each night?
Yeah. Normally it's 5 or 6. That's why I made that form like that. Another Worthington teacher made that form, so I will not say that I made it, but I stole it.